All right, this is our last video in section 8.2, and I know I've thrown a lot of stuff at you already, solving by substitution, solving by elimination, getting one answer or lots of answers, infinite solutions, or maybe even getting no solution. I'm going to throw one more thing at you. Woo, fractions, right? Everybody's favorite. Okay, but we can deal with fractions, and we've talked about dealing with fractions before. So look at example number 5 with me. It asks us to solve the system either using, actually it says using elimination, right? The problem is I've got a lot of fractions, and I really don't want to have to deal with fractions. I don't want to have to deal with getting common denominators and worrying about all of that, especially when I have lots of different variables to deal with too, x's and y's. So as soon as I see a problem like this, the first thing I'm going to do is I'm going to try to get rid of the fractions. If I can get rid of the fractions and make my numbers nice, cute little whole numbers, it's going to be much easier to deal with. So let's focus on each equation individually. Remember, we talked about this in a previous section, that anytime I have an equation and I have fractions in it, that I can always get rid of those fractions by multiplying every single term by the common denominator. So in this first equation, it looks like my denominator are either 1 or 3's, right? And so my common denominator would be 3. So I can get rid of the fractions in this first equation by multiplying every single term by 3, as long as you make sure you do it to everybody, right? And so when I do that, I end up getting the equation 3x minus 1y, right? The 3 and the 3 divide into 1 equals negative 3. And you can put the 1 there if you'd like to. So let's do the same thing with the second equation. I've got a whole bunch of fractions with a whole bunch of different denominators on that second equation. Let's go ahead and get rid of all those fractions by multiplying every single term in this equation by its common denominator. So what would be the common denominator between 2 and 8 and 4? How about 8? So let's go through and multiply every single term in this equation by 8. 8 divided by 2 is 4. Don't forget about the negative 4. 8 divided by 8 is 1, 1y. And 8 divided by 4 is 2. So now I have two nicer, cuter equations with whole numbers that are much easier to deal with. These two blue equations are equivalent to the first equations, just without fractions, so much easier to deal with. And if you notice now, they're in columns, and aren't the y's already opposite? I have a negative 1y and a positive 1y, so I'm already perfectly set up to do elimination, which is perfect. If it wasn't so perfect, I might have to do one more step and get either one of my variables to be opposites, but hopefully you've already practiced that part. All right, let's add these two equations together. Negative 1y and positive 1y zero each other out. I have a 3x minus 4x, which is a negative 1x, equal to negative 1. Now I can get this negative 1 away from the x by dividing both sides by negative 1. Negative 1 divided by negative 1 is positive 1. So I end up getting x equals 1. All right, now that I have x equals 1, I've got to figure out what y equals. Okay, here we go. You could either pick one of your original equations and plug 1 in for x to find y. Either one of these. I'll do that now, but then I'll show you a better strategy, an easier strategy that might work too. So I'm going to pick the top equation, the original top equation, and instead of an x, I'm going to plug in a 1. So using this top equation, I have 1 minus y over 3 equals negative 1. Now you notice that my variable is here, and I want to get y by itself. So I'm going to get rid of the one farthest away first. I'm going to go ahead and get rid of the 1 by subtracting it to both sides. When I subtract the 1 from both sides, I end up getting the equation negative y over 3 equals negative 2. Now I still need to get rid of the negative 1 and the 3. Now you can think about this a couple different ways. You can divide by negative 1/3, which is really the same thing as multiplying by the reciprocal. Or you can multiply both sides by 3 first and then divide by negative 1. You should end up getting the same answer. I'm going to go ahead and multiply both sides by 3. Those 3's divide into a 1. And so I end up with an equation that says negative 1y equals negative 6. Now I can get rid of the negative 1 that's next to the y by dividing by negative 1. That would be really the same thing as multiplying by the reciprocal, 3 over negative 1, right? All right, negative 6 divided by negative 1 is positive 6. So I end up getting the solution to the system of 1, 6. Now, it was a little bit harder when you had fractions and you plug it in. So what you can do, instead of plugging it into your original equation that has fractions, you could have actually plugged this one into either one of these equations because they're equivalent to the original ones, but they don't have fractions. Try it and see if you get the same answer. You should. So, as long as you plug it into one of your originals or a version of the original, you should be able to get your other variable. So the solution to this system is 1, 6. One solution.